Hi everybody, we are ready for the last section that we're going to do over the summertime. This is chapter 1, section 6, and I'm only going to pick and choose some things here because we get into a much more detailed discussion of these concepts later in the book. So I'm just going to pull out things that I know that we're going to have to need along the way because most of these concepts are studied later on very carefully. But we do want to just touch on the fact of polygons for just a second. Polygons are closed figures. The sides that have a common endpoint are non-collinear, so that eliminates a figure like this from being a polygon. Polygons, they have the points where their sides meet are the vertices, just like we talked about the vertex of an angle. Vertices is plural of vertex. You have either convex or concave polygons. Concave polygons, if you extend the sides, some of the extensions will go inside the polygon. I like to think of it as caving in. And we will give much more of our attention to convex polygons as we study, but that's still not the most important part of this section, I don't think, for now. Now, later it's going to be extremely important, but for now, let me get to what I want to talk about. All right, over here, right here, these terms are really important, and like I said, they'll be even more important later. But you need to go ahead and be committing these to memory if you don't already. A three-sided figure is a triangle, like a tricycle. A quadrilateral, like the quad. On a lot of college campuses, a four-sided yard. You have a quadrilateral, a four-sided figure, like a square or a rectangle, a rhombus, a trapezoid, etc. Pentagon has 5 sides, like the Pentagon in Washington. Hexagon and heptagon, sometimes kids get those turned around, but just remember that hexagon has the X, just like 6 has an X in it. So your hexagon, it has 6 sides, heptagon, 8 sides, octagon, like an octopus, has 8 sides, and so forth. Decade is 10 years. Dodecagon, like the is it the dodeca? There's some islands, the Dodeca Islands or something. There are 12 islands. It's a group. So you can find ways to remember these. Over 12, we just refer to it as an n-gon. In other words, if I have a 13-sided figure, I'm not going to use a special name for that. I'm just going to call it a 13-gon. Or if I have a 25-sided figure, I'll just call it a 25-gon. And again, these are things that we'll study even in more detail later. But every once in a while, they will use a little something from this to illustrate a point. And so we just kind of want to make sure we have a taste in our mouth for these so that we're not blown away when they come up, okay? So just spend some time with that. Be familiar with those so that if those names were to come up in an exercise down the road, you wouldn't be just totally freaked out by it. This is where you're going to need to spend some time. These area and perimeter and circumference formulas we will study in great detail in the spring. But there will be a few exercises that we do before we get to those that will call upon us to use these really basic formulas. I'm assuming, and I hope you've had them all before now, but just in case not, let's talk about them. Perimeter, as you know, rim is in the word perimeter. That means we're going to find out the distance or the length around the rim or the outer edge. So in our triangle, when we want to know the perimeter, we've got to add up the lengths of the 3 sides that are the edge. In a square, we have 4 sides that are the same length. So if we know the side of one, the length of one of those sides, we just need to multiply it by 4 to find the perimeter. In a rectangle, we have 2 lengths that are the same. We have two widths that are the same. If we add those together, that gives us the perimeter. And the perimeter of a circle, if you will, is called the circumference. The circumference is found by multiplying the constant of nature pi by the diameter of the circle. And a diameter is 2 times the radius. So we've got two expressions for the formula of the circumference that we use a lot. And I'm sure you've seen those before. Now the area, the space that's covered inside the square units needed to cover the surface, is in the next row that we have here of formulas. The area of a triangle is 1/2 the base times the height. And remember that the height is not going to be one of these slanties. It's going to be that altitude, that straight height. You need to remember that the base and the height will always be perpendicular to each other when you're finding the area of a triangle. The base will be a side of the triangle, but the height does not always have to be. The height will be if we have a right triangle, but if we don't have a right triangle, the height is going to be the inside altitude. The area of a square is just a side multiplied by itself. It's like finding the number of squares on a checkerboard. You would multiply how many squares are on one length by how many squares are on one width, and that would tell you how many square units are all over the checkerboard. Similarly, the rectangle, we would multiply one length times one width. It just so happens with a rectangle, the length and the width are not the same number where they are in the square. And then for the area of a circle, we're going to multiply pi times the square of the radius. So from the center of the circle to the edge is a radius. We'll take that number and multiply it by itself, and then multiply that by pi. If our book asks for an exact answer, then that means we leave pi in the answer. We don't multiply on the calculator by the pi button. So if I have a circle with a radius of 6, and I want to know the exact area, then that would be 6 squared times pi, or 36 pi, and that's how I leave it if I want an exact. Okay? They give you some examples down here, but again, from past experience and from knowing the previous curriculums, you've had exposure to these before, so this is sort of just a little bit of review. Let me go to the next page. I may want to come back. Yeah. A couple of times before we study the Pythagorean Theorem, they call upon us to use it. So I want to go through the Pythagorean Theorem with you one time. Let's just look at the picture they've given us here. We have a right triangle. Let's blow it up a little bit. There we go. We have a right triangle because this is, again, that symbol that tells us we have a right angle. And if a right angle is in a triangle, then we have a right triangle. We're given the two legs of that right triangle, but this C over here is the hypotenuse. Now let me tell you about the hypotenuse. The hypotenuse is always the longest side, and it's also always across from the right angle. Okay? So when I set up the Pythagorean theorem, it's always the hypotenuse squared equals the sum of the square of the two legs. This is always the hypotenuse, the side by itself. Sometimes it's given to us, so we would plug in a number for the C, and in this case, we're trying to find the length of the hypotenuse. So my hypotenuse squared equals 7 squared plus 7 squared. It doesn't matter which of these we put in for A or B. Not only because in this case it's the same number, but because addition is commutative. That's from Algebra 1. So it doesn't matter the order that I add. So it doesn't matter which is A or which is B as long as they are the legs. But the hypotenuse must be the side by itself. And remember, the Pythagorean theorem only works for right triangles. You never use it for any triangle unless that triangle has a right angle in it. Okay, let me get back to my ciphering here. This is 98, so C is the square root of 98. That's going to simplify. Since 98 is 49 times 2, this is 7 root 2. This is my exact answer because I didn't try to round off my root 2. Okay, so C equals 7 on root 2 is my exact calculation for C. But remember, and I may be over emphasizing this, but I try to learn from mistakes I've seen from students in the past, and I want to make sure I keep us from making that mistake. If I have a right triangle, let's put another right triangle in here. If I have a right triangle, I may be given the hypotenuse and given one of the legs, and it may be asked to find a missing leg. I still put the hypotenuse length by itself on one side. Okay, the error I'm trying to keep you from making is by putting the unknown. This is what I get a lot. Excuse me. I get this error a lot that students want to put the unknown in the Pythagorean theorem by itself on one side, and that is just not accurate. You have to have the hypotenuse on one side, whether you know it or whether, as we were doing up here, we're looking for it. So we've got to find out an unknown leg. So let's just go ahead and do the arithmetic. When we subtract 36 from each side, and then we take the square root of each side, we get a plus or minus 8, but remember, we can't have a negative measure, so we throw out the negative, and we're just going to keep the positive. Okay? All right, let's move on a little bit. I hope that is that's clear, what the point I'm trying to make there. Distance formula we've already talked about. So I won't go back there, but that's another formula we need to know. As we look at these problems here, number 20 illustrates what I was trying to talk about a while ago with finding the area of the triangle. Note that we have 1/2 the base times the height, and the height is this 8. It's the distance from the vertex down to the line that has the base on it. So your base and your height in a triangle have to be perpendicular to each other. Okay, here they are. So you can just use those as the base and the height. But when we're talking about an obtuse triangle or a triangle that's not right, we have to calculate the height. Okay, I think that takes care of everything I wanted to mention. Okay, I think that's pretty good. So, again, I just sort of wanted to point out some things in that sixth section. There is, you'll see when you get your book, a 7th section to this chapter, but I don't want to touch that until we get into the spring and we do that chapter all at once. It's a little early, I think, to bring that in. There's some concepts that we need to understand better to make that easier and help you retain that information a little bit better. So I like section 1 through 5, and then let's touch on this 6 a little bit to be prepared to use any of those formulas that they listed in there that might occur. And then section 7, which of course you don't have access yet, but section 7 will be something that we will thoroughly cover in the spring when we look at areas and volumes, etc. So I guess that is it for us for the lectures for the summer. Again, if you have any questions, please leave comments or send me an email. All those instructions are there in your Google Classroom. Make sure you're doing all your work in pencil. We will collect your homework on the first day that we meet together and have class. Remember that you will not have a major test over this, but we will have a quiz over this information in the second rotation. I don't know exactly which day yet. I'm making these videos well before I know the schedule that we will be having in the fall. So I don't want to lock us into a quiz date. It's way too early to think about that right now anyway. But I want to know your questions. I want to know if there's something that I have assumed that you've seen before that you haven't. I need to know those things because we don't want to sweep anything under the rug. We want to make sure everybody is on an equal footing and understands thoroughly before we go into chapter 2. And if you don't have, well, I don't have any other thing for you, and I'll just look forward to seeing your questions and comments. And I will see you when school starts. Have a good rest of the summer, everybody.